Oh yes. It's Brady
Caw.
and Levi.
Levi.
Do the bird noise.
Caw.
Caw.
Nerdish.
It's nerdish with a 3, not nerdish with an E. Why?
8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Yes, because nerdish with an E was taken.
And that's why we do it 8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Thank you for giving that reason for a question that I didn't ask.
That's sort of like the way we eliminate answers on the reading section.
Yeah, that's true. And I guess the other sections to a certain extent.
I think it's important when doing a rap to listen to the beat that's happening in your ear. Otherwise, you have a problem staying on beat.
Correct. We do the ACT and SAT, they're standardized tests to help you get into college.
We don't tutor rap. We shouldn't ever do that.
No, we're not pretending to be tutors of rap, even though we're really good. Sometimes you can be really good at something, but not be a good teacher. Case in point.
Point in case.
Point in case word.
Point in case something bad happens.
Like this.
Yes.
I think we're enriching your lives by you watching this.
I'm getting a phone call from a friend. Do you think I should pick it up now?
The phone call just was dropped. Maybe he'll leave you a voicemail.
Next time, I'll pick it up during the stream. That way we can all talk to my friend Steve.
If you think this is not very high quality, don't worry. We're gonna do it again in 2 weeks.
Also, we're much better quality when we're teaching you all the things in a number tree.
Like prime factorization?
Yeah.
Oh, that's fun.
Yeah.
You break a number down into its prime parts until you can't break them down
We
anymore.
can probably do that right now.
Yeah, we might.
Okay, so let's say 32.
I was going to say 30. That's so close.
Oh my gosh.
All right, break it up.
Okay,
Any way you want. 2 and 16.
Okay, 2 and 16.
2 and 16. 16 is 4 and 4.
Okay, 4 and 4. Oh,
And
interesting.
each
So
4
16
is
a perfect
2,
square.
2. Yeah, exactly.
Okay, 2 and 2 and 2 and 2.
So it's 2 to the 5th.
Yeah, it's 2 to the 5th.
2 to the 5th, exactly.
Whoa.
Yes.
That's pretty cool.
You see that? It's that quick. Now you know. Think about that for our whole show.
Now stop watching the stream because you've learned everything necessary.
Bum, 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 bum. We're in a box. You can help us by asking us questions in the hope that someday we can escape. Welcome, welcome. Come one, come all. I should probably turn on the message chat stream. Sorry about that. We can't see your messages right now because I shut off that monitor. Because Levi said, hey Brady, shut off that monitor so we can't use it. And I said, why would I do that? And he said, I don't know, but do it. And so I did do that. And now we can't read your messages.
Mm-hmm.
Well, we can read your messages now. Levi, put it on the screen. Put it on the screen.
Mm-hmm.
Make it big. Good. All right. Well, welcome to Nerdish. I'm Brady. Levi is eating, I think, yodels. Is that what you're eating? That's good. That's good for you. You gotta eat more food that will not perish ever. That's always good for you, because that means that you'll live longer. Because you're eating
It
food
won't perish inside me.
that won't perish inside you. That's the problem with most food, is it perishes inside you before you actually get to, digest it.
Watch this, watch this.
Nice. I bet I can do that. Well, I bet you, so. Anyway, today we're doing matrices, and Levi's doing 4 uses of commas. What are you doing?
Yes.
Are you sure?
No. Yes.
How do you... You gotta take a vitamin, man. I'm telling you.
Could be
I'm
vitamins.
telling you. All right. Woo! Matrices. Big time. Big time matrices. Matrices are huge. They're so big. That's the first thing you have to know about them. That looks like an H. Let's cap that off. Matrices are the plural form of matrix. And matrix is what we all live in, and we don't even realize it. This is not the real world. This is just a simulation so that robots can use our bodies as energy sources.
It is statistically more likely that we are in a matrix.
Yes, by a lot.
It's like 20.
20%? More likely? I feel like you're just getting that number out of nowhere. That's what you said, it's like 20. A little approximate, a little squirrely equal sign.
Yes.
Very good.
Wait,
Can you do it? I approximate you.
I like you.
Oh, that's good.
Yeah?
He likes me. It's like. I never thought about that before. You actually care about me? I thought you killed me.
You thought I killed you.
Yes. I thought I was dead by your hand.
I believe, sir.
All right. All right, guys, let's talk about matrices here. Matrices are arrays of numbers. They can be all sorts of things that represent different real-world situations. So let's give you a couple. Let's say we got 1, 7, -3, 4. That's a matrix. Let's give you 9 and then 12. That's a matrix. What about, I don't know, just 4? That's a matrix. It's also just 4. And then why don't we also give you one of these? Oh, jeez. That's not supposed to happen. 13, 11, 9. These are all examples of matrices. Now, as you can tell, they are different dimensions. All right? What we have to first talk about is what dimensions of a matrices. Oh my gosh. What dimensions of a matrix are, how you identify them, and how you categorize them. Okay? So the general rule here is rows by columns. That is the order that you give the numbers in. All right? Now, rows by columns might be a little difficult to differentiate between, but I always think of columns as vertical things in a building. Vertical columns, okay? So rows are sideways. So this first one, we have 2 rows and we have 2 columns. So this is a 2 by 2. Fantastic. This next one, we have 2 rows and 1 column. So this is a 2 by 1. Exemplary. This next one, 1 row, 1 column. It's just a 1 by 1. And this last one is 1 row, 3 columns, so that is a 1 by 3. Fantastic. Why are dimensions important? Because there's certain operations you can do with matrices that the dimensions have to match, or maybe they have to fit together in a specific way. And if you don't understand how to categorize their dimensions, you won't be able to tell if matrices can be added or subtracted or multiplied, all that kind of fun stuff. All right, so we're going to start off with the easy stuff, all right? Perhaps the easiest thing, you know what, here's what we're going to do. I'm going to call these matrices, we got A, we got B, we got C, and we got D, okay? Yeah. We're going to start off with, if I wrote 4B, what would that mean? Well, 4 is what we're going to multiply B by. So I'm going to write 4 again, and then I'm going to write B, which is 9, 12. This is called scalar multiplication. It's just like distribution. We have a number in front that's being multiplied by both things. So we're going to end up with another matrix, but each of those entries is going to be 4 times bigger. So this is going to be 36, and this is going to be 48. All right? That is scalar multiplication right there. It is probably the easiest matrix operation that exists known to man. There might be some matrix operations that a highly intelligent species of aliens, species is singular, that it knows about. That's a hard one. But we haven't actually figured that out yet, so just for now, we like that a lot. Okay. Now we're going to add some matrices, and I actually need to create another matrix. We're going to call it, I got to use blue. I have to be consistent. Otherwise, Levi gets mad at me. Levi's mad at me. All right, we're going to call this E. And this is what E is going to be equal to. -3, -1, 2, 6. Great. So the dimensions of this, 2 rows, 2 columns, it's a 2 by 2. Next thing you might need to do is matrix addition. All right, this is not as hard as you think. So we're going to do A plus B. So let's rewrite the matrices with a big plus in the middle. A is 1, 7, -3, 4. And we're going to be adding B, which is, wow, Not B. I apologize. That should be E. I just created a new matrix for exactly this purpose. So I'm slightly embarrassed, but not too embarrassed. A plus E. E is -3, -1, 2, 6. How do we add matrices? If you've never done it before, it's probably exactly what you assume, which is we add corresponding entries. So we're going to get a 2 by 2 matrix to end with, and we're just going to add all the things that are in the same spot. So 1 plus -3 is going to be -2. That's going to go in the top left corner. 7 plus -1 is going to be 6. -3 plus 2 is going to be -1. And 4 plus 6 is going to be 10. All right? That's all it is. That's literally all it is. Matrix subtraction works the same way, except you just subtract the numbers that are corresponding entries. You know how to do that. You got this. All right? That stuff isn't too difficult. The funky stuff comes with determinant and then matrix multiplication especially. Okay? So with determinants, they sometimes will give you the formula for a determinant, and sometimes they'll just ask you to find a determinant. What a determinant actually is something it's very simple to find. What it means is it's very complicated, and you get into it when you do linear algebra, which sounds simple, but it's not. It's way down the line of math class. It's after multivariable calc. But anyway, the determinant. If you have a matrix that is 2 by 2, you can only find the determinant of a square matrix, I believe. I am pretty sure about that. And they're never going to ask you for the determinant of a 3 by 3. It's always going to be a 2 by 2 that they're going to ask you about. So you have 4 entries, A, B, C, and D. If you want to take the determinant, what you do is you find the product of the top left and the bottom right, so that's A times D. And then you subtract the other diagonal product, which is going to be B times C. So AD minus BC. Let us do an example. We're going to do an example. So the determinant of, actually, you know what? Let's say matrix A. I think you're supposed to put it in brackets like this. Yeah, maybe it's something like that, I think. I don't know, you know. Fantastic. Determinant of matrix A. Well, let's rewrite A again. So we're taking the determinant of matrix A is 1, 7, -3, 4. Levi, no one has messaged yet. Should we get worried?
No.
Okay. Hey, if you're watching, we're not sure if our chat's working. Just send us a little message, and then we'll be a lot more relieved, excited, enthused.
No, we have one viewer. That's fine.
Jazzed.
And it's probably me.
Okay. All right. So the determinant. We multiply this diagonal here. That's the first thing we do. So 1 times 4. Great. And we subtract the other diagonal product, which is going to be 7 times -3. So 1 times 4 is 4. We're subtracting -21, so we're actually adding 21. And so we get 25. The determinant of matrix A is 25. Okay? So, just remember, you multiply these things, great. Then you subtract these things that are multiplied together. All right? AD minus BC. Have that just sink in for a sec. Marinate. Sublimate, which is a word that means a solid turning into a gas directly. Dry ice does that. Have you ever seen dry ice? It turns into a gas immediately. It is solid carbon dioxide. Pretty wild. And then if you go from gas to a solid, that's deposition. Or maybe it's deposition, but I'm going to say it's probably deposition.
Yeah.
Because that sounds kind of like more professional sounding. Isn't that a legal term?
Yes.
What does it mean?
You write a deposition that, yeah.
Good. All right. So it's something that you write. That's what it means.
Well, my mom writes them.
All the time?
Yeah.
Nice.
Not as much anymore.
Oh, since the accident?
Since she retired.
Yeah, the accident. She didn't mean to retire.
Yeah, that was a big mistake on her end.
Yeah. Huge accident. Levi, I feel weak.
She always retires. Yeah, I'm not surprised you feel weak. Makes a ton of sense.
Yeah, I think it does too. Very good.
You're operating at a calorie deficit.
Correct. My body is adjusting. Okay. Gotta let it dry. Gotta let it dry, Levi. Don't do it yet. You gotta let it dry first. Good. Good. Gotta let it dry. All right.
Let it dry when no one is around.
Yeah.
Okay, are you done with matrices or no?
Dude, multiplication.
Oh, that's the easy part, right?
Are you kidding me? That's the hardest part.
Almost as hard as division.
There's no such thing.
I meant emotionally.
Division, they do inverse stuff. Take the inverse of a matrix. It's like you solve systems of equations with matrices. Plug it in. When no one is around you, take a look around, and if no one's there, then plug it in.
Oh.
All right, matrix.
Can I give you a matrix? Matrix? Yeah. Matrix.
Well, I first want to talk about
A, B, C, D, W, X, Y, Z?
Hold on. I first want to talk about the dimensions having to be a certain way, and then you can give me a matrix. Sorry, man.
I'll step away.
I'll be there in a sec. This matrix has 2 rows and 2 columns, 2 by 2. This matrix here is going to be a 2 by 1. Listen very carefully. If they're asking you to multiply matrices, the only way that you can do that is if you write the dimensions below like this, and the inner dimensions match. If they do not match, you cannot multiply these matrices. You'll see why in a second, but those have to match. And then your answer matrix is going to have the dimensions of the 2 numbers that are left. We're going to get a 2 by 1. Going to get a 2 by 1, which is going to look like this. It's going to be 1 entry there and 1 entry there. Okay, Levi.
Yes.
In explaining that, I've already written out 2 matrices.
Oh.
I'm sorry.
No, it's fine.
I'm sorry, man. All right, so here's how you multiply them. And Levi showed me this trick, and I've never forgotten it because it's so incredibly smooth. Just like you just shaved, and you're very smooth. So first matrix, you rewrite that. 4, 6, -1, 2. Hey, Uncle Bill's here. Hey, Uncle Bill. A multitasker flies by. Thank you for multitasking and including us in your tasks. That's very nice. All right, the second matrix you're multiplying by, you're actually going to put above. 7, 11. Okay? Our product matrix is going to be right here. Here's what you do. You're going to be multiplying pairs of numbers and adding them together. Okay? It's kind of weird. In this top spot here, take a look at the row and the column that point to that. We have 4 and 6 that are on the same row, and 7 and 11 which are in the same column. So here's what you're going to do. You're going to multiply the first number 4 by the first number up here 7. That's 28, and then you're going to add that to this number times this number. Okay? So you got these 2 pairs of numbers, you're multiplying their little partners together, and then you're adding the 2 sums or you're adding those 2 together. Okay? So 4 times 7, I'm going to put it down here. 4 times 7 plus 6 times 11 is going to be 28 plus 66, which is going to be 80 plus 14, which is 94. So 94 is going to go here. All right? What? I can't, Kevin, I can't say the next thing, man. I can't say the next thing. Gamertune, that ACT was horrible last week, especially that science section. Oh, man, I heard the science section was pretty tough. First row. Yeah, first column. Guys, this is my freshman year roommate and one of my best friends from college. K-Mad Cooks.
Oh, is this the one you didn't like?
No, this is the one I did like. You're thinking of the one that I didn't like. Right. Kevin, how's the cooking going? I'm doing matrix stuff, man. I'm just cooking up matrices. And these, oh man, these smell like vinegar.
That smells like vinegar.
It smells like vinegar because that's the cleaning product we use. I'm guessing you were just scrolling by on Facebook and you saw that we were live. Is that what was going on?
He's on Twitch.
Oh, he's on Twitch. You might need to add some more salt on that first matrix. Well, hey, I would believe you. You're the one that cooks. I need to cook more, man. I'm steadily drinking less Soylent as time goes on. So I'm getting better at cooking. I bought vegetables the other day, which is kind of a big move for me. Anyway. Now we're going to deal with this bottom entry. So it's the same deal. We're going to pair up. Did you hear about those questions? The science questions? GamerTune, give me some details, man. What kind of science questions are we talking? Are they like previous science knowledge questions that were really difficult? Yes. What concepts were they asking about, if I may be so intrusive? -1 times 7 plus 2 times 11. That's the other thing you're going to have to do. H2O density question. Oh, did you have to know the density of water to be able to get it right? They didn't give it to you. So we have -1 times 7 plus 2 times 11. It's going to be -7 plus 22, which is going to be 15. 15. That right there is your matrix product. It dealt with the ideal gas law. Oh my gosh. Yes, KMAD. KMAD, we got to talk on the phone, man. I have lots of updates, and I'm sure you do too. It dealt with the ideal gas law. That gas law is like so ideal.
Is that PV equals NRT?
Yeah, good old Piv nerd. Yes.
He's not remembered from the Enlightenment well at all.
What?
Piv nerd?
Yeah, he's not remembered?
And yeah.
Because he was the one that discovered it, right?
Yeah.
And it just so happened to match his name.
Piv nerd.
Get out of here. H2O density question. The density of water is 1 gram per centimeter cubed, which is a pretty nice density if you think about it. But if you don't think about it, then it's not a nice density. Levi, you want to give me 2 matrices to multiply together, then it'll be your turn?
Yes.
Okay.
Do I need to raise something first or no?
I really need to get better at like putting things off to the side.
Yeah, you always do that.
I can't help it. Well. Yes. If you know how to use that part of your calculator, then matrices are going to be a breeze.
Although there was that ACT matrix on one of the last ones in last year where using a calculator wouldn't really help.
What was the question?
It was basically saying you have
teachers buying tickets.
Yeah, the teachers and tickets.
You have to understand how multiplication works. Right.
Yeah.
Right. It would take a while for you to use those because you'd have to multiply them in all the different ways and figure out, oh, this is the amount of money they're going to spend.
Yeah, you have to solve it yourself.
But yeah, it's not worth it. It's just not worth it. Plug it in. You just need to plug it in.
GamerTune, do you have any? Are you taking the ACT again or going to the SAT? Do you have anything specific that you'd like to study aside from Brady and his weak form?
So weak. All right, give me some matrices. Probably ACT again. That's good. Show that test who's boss. Give me some matrices.
Yes. I will give you a matrix. What sections are tough for you? You think you got a 34. We'll see. We will see about that. Yeah, so that means you don't have too many concepts to learn, at least. It's just going for those last couple of points in each of the sections. Any sections that are just done, 35, 36 every time? Big curve going in which direction? Good or bad for you? 2, 3, -1, 0. Hey, Bird.
Yes.
Go ahead.
Very good. Very, very good. Oh, this will be fun. All right, so like always, I'm going to... Yeah, if you got a 34, you're done. You don't need to take that again. All right, let's talk about dimensions here. This is a 2 by 2, and this is going to be a 3 by 1. Levi, I can't multiply these.
What?
I can't multiply. These two numbers don't match.
How do you know?
Because they don't.
Oh.
You know the curve for ACTV04? Yeah, I can input it to you in like binary if you want me to. So it's like you're gonna have to slow this down, but and the curve is you gotta undo the binary there. You'll get it there. There's a lot of data I just transmitted to you. Levi, I can't multiply these matrices.
I'm so sorry.
Yes.
I had no idea.
All right, I got a riddle for you, Levi.
Do you?
A man and his son were driving in a car, same car, down a mountain road. Damn it. Never mind. Should I tell them? Otherwise, it's
No.
like, what just happened? Fine. All right, we got a different matrix now. Good. All right, this is a 2 by 1, which means we can multiply
You're
these.
so cranky.
I haven't.
I know.
I'm weak, man. I'm weak.
So weak. It's okay. It's okay.
It's been a long week. It's been 5 things that you look at me, 5 things in your eyes and say you're crazy.
Right. Yep.
Gamer
Gamer 2. What would you like to work on? We don't know the curve. The curve's gonna be the curve. You just wait and see. Okay. You just sit there and you wait. But also tell us what you wanna. If you want us to teach any concepts that you're not super comfortable with, or anything that you remember from the test that makes you know that you didn't get a perfect score for whatever reason. Math is sometimes the easiest thing to remember. Eric, what is up?
Eric. Eric, you're a goon. You're an absolute goon.
We gotta tell Eric though, because he needs some help.
Yeah, well, Eric, you know you could use what's in the corner here. Alta ipsum. It's a it loosely.
It means Greek in Summit Yourself.
Oh, that makes sense.
Right.
It means Greek in Summit Yourself.
Yes.
Yeah, alta ipsum is it means do the best you can in Latin, just to make sure that Levi's fact is disproven. And what it is, it's an application that you can have on your smartphone or your computer that helps you plan out your academic career. We're talking goal planning. We're talking grade
essay
tracking.
planning, we're talking
homework.
outsourcing your stress.
Outsourcing your stress, exactly. If you try to think about all the things that are due in your head, you're going to go crazy.
It becomes another parent.
Right.
And everybody wants another parent.
Yeah, a third parent. It's an
Yes.
external brain. That's what it is, right?
Yes.
Outsource it to your external brain.
Yep.
It'll give you alerts as to when you need to do things.
If
like
the artificial intelligence apocalypse does come, it will protect you.
yes, you know the rule that for the most time that opposite forces attract. For
Yes.
the most time, that one did not. What on the science section, or what do you mean? Anyway, there's a free month. If you sign up for Alta Ipsum, you get a free month, which means that it doesn't cost you anything. That's what free means. Science section. Oh, okay. That one did not. What kind of forces are we talking about that didn't? You know, it's not that opposite forces attract. It's like
Equal and opposite of forces.
no,
Right.
no. If
Only
we're talking about
those
attraction, it's opposite charges.
Magnets.
Yes, opposite charges. Whether we're talking about magnets or we're talking about electricity, opposite charges attract, like charges repel. So it's not that forces attract each other. But I think that's you probably meant charges. But you're saying that it didn't attract if it was opposite? I want to hear more. Anyway, download Alta Ipsum, and you'll be stress-free for the rest of your life.
Yes, and very stressed if you don't.
Correct. All right, I'm out of here.
Where are you going?
I'm going to be right there.
Oh, are you done?
Yeah. I'll do this one if you'll do that one.
Okay.
Very good. Very good.
Hey, Eric, commas. I'm going to go through them. So if anybody wants to talk about commas, let me know. There are 4 uses on the ACT and SAT. If you don't know them, then we'll talk about them.
Oh,
Eric.
repulsion means repelling. When two things repel, it means they go in the opposite direction. You either attract or you repel.
Right.
If you're repulsed by someone, you want to get as far away from them as possible.
Right, and the best way to make sure that if you are in contact and then there is a repulsive force, which is not really a force, but there is a force repulsing you, you can use tight bond glue.
Yeah, it's original tight bond wood glue.
Right.
Any kind of particles, you put wood glue between them, and then they'll stick together. And that's why it's one of our sponsors, because Levi and I have
A
tight bond.
They don't pay us anything,
Mm.
just so you know.
Oh, there's glue everywhere. I'm kidding.
Can we draw a repulsion field? Can you draw a repulsion field?
Yeah, it wouldn't really be called a repulsion field. It could be called a magnetic field. So, all right, if you got a positive charge, which can also be thought of as like the north side of a magnet.
The north side.
The north side of a magnet. You got all of these field lines pointing away from it. The reason why they point away from it is because the way that we consider charges and fields is what would a positive charge do if it was nearby? A positive charge would be repelled by this thing, so it would want to shoot away. All right? So if that's positive and we have a negative charge, the field lines are going to be pointing towards the negative charge because a positive charge would love to go towards a negative charge. All right? Those are them separately. And then if you want to do them together, this is what it would look like. I'm going to put it up here. You got a positive and a positive. They're both sending out forces away from each other. And these forces are going to look like this. Basically, the field lines are going to repel each other. It's going to be this kind of...
It looked like that.
Yeah. These lines don't connect because these things are going to repel each other. They're going to want to shoot in two different directions. Whereas
Hang out for a bit.
a positive and a negative are going to attract each other because the positive field lines point from positive to negative. So these things are going to love each other. Many dots, right? Many dots. Are we talking magnets, electricity, perhaps gravity? What are we talking about here? What was the actual section about? So I'm trying my best here. Trying my best. ICDC is not essential. Items in series. Fanboys. Oh, look at that. Magnetic fields. Yeah, magnetic fields. That's what these are. They can also be thought of as electric charges, but just switch it with like N and S for north and south, and you got the same picture. So if two things repel, they got it like, you know, a north and then a north, then they're going to want to shoot away from each other. That's what the forces would look like. These things are going to want to go whoop. And if instead you had a north and a south, now it's not like you can have one pole separate from each other. You can't just have a north hanging around, because if you've ever seen a magnet, it always has a north and south pole. But maybe think of this more as like electric charges. The north is going to want to go towards the south is going to want to go towards the north. So that's attraction, that's repulsion. Magnetic fields, okay, I think I got it right. Hopefully. Okay, Levi.
Yes.
You can now do your worst.
Okay. ICDC, non-essential, items in a series, fanboys. Close. Very close, Eric. You can erase Eric's thing too. DCIC. Because an ICDC would be I whistle. What did the English section test if not the usual stuff, gamer?
Spanish?
I whistle while I walk. So, while I walk is your dependent clause. This is your independent clause. So, dude, you never use enough.
What's up?
So cranky.
No,
Dude, you gotta eat more.
I know. No, I think I ate too much. I gotta eat less.
Okay.
That's what it is. No. What did it test on, Gamertune?
So ICDC, you don't need a comma. Because the while separates them, you don't need to separate them with a comma. It's DCIC. While I walk, I whistle. Not that many appositive phrases. There's usually a lot. Only one appositive on the exam.
That's unheard of. There's usually way more. They love testing that.
If that's the case, that's super surprising. What were the questions then? Were there fewer grammar and more, appropriate word choice and, sentence organization, and should we add, should we not?
Less? It's less, not fewer.
Yeah, Gamertune, you got to get out of those magnetic fields if you can keep doing that. You can use Alta Ipsum to remind you.
Well, yeah, Alta Ipsum saved my marriage, so it can do anything.
Oh gosh, we have our replacement for SCADA, I think.
We have Eric TLT.
Yeah.
Eric, keep it up. We enjoy you.
A lot of appropriate word choice. That's a bummer for a lot of people. Let's see. We could do. We did that yesterday. How do you spell left in the past tense? Do you have an A or no?
L-E-A-P-T.
For past tense, and then the past participle is L-E-P-T?
Oh, so leaped is past tense and I have leapt.
Yeah, leaped. It's can you check that? I feel like everybody always mispronounces that. I've never seen it on a test. Okay, so
Oh. The past tense of leap is leapt.
how do you spell that?
L-E-A-P-T.
So this leaped is not a word then.
I'm gonna check.
That's what I thought. Thing.
Oh, geez. Past tense is leaped. Past participle is leaped. So where does leapt come from? There's some.
I think it's just the pronunciation. It's just you don't pronounce it you don't do the E, you do the E. Okay, so in this one, so you could put a comma, I mean, the possible places are probably there, and there, right? Going up. Yes.
They're both past tense and past participle.
So you can just choose.
Yeah.
Great. I leaned into the air. By the way, people said it was reuse of September 2017 and June 2018. Interesting. Very interesting. Wow, I really dropped that down. The eye is kind of leaping into the air. Okay, so Eric, you said you want a comma after joy and after student. Does anybody else have any other thoughts on this? Where might we want commas? I could give answer choices. You know what? Maybe I just will. So we have joy, student. I don't want to write the whole thing though. Do we want just this comma, just the second comma, just the third comma, or some combination? So that's how I'm going to do it. Just 1, just 2, just 3, 2 and 3, or 1, 2, and 3. Maybe instead of Griffin comma, instead of student comma. Okay. So here's the deal with this one. You got to figure out what these commas are for. The first comma would be the non-essential type comma to offset this, full of joy, right? Because this piece is describing, maybe I'll do that in yellow. Yeah, I'll answer the question in yellow. 1 and 3, okay? So we have this piece, which is a non-essential, and that should be describing the subject that comes after it. Now we're not sure of what the subject is. We know that this is the verb, right? So this is our verb. That's easy enough. There's no other verb in this sentence. Full of joy, student Blake Griffin leapt in the air. Leapt into the air, leapt in, whatever, it doesn't matter. I would say we want a comma here because then we start with our subject. Our subject is some amalgamation of student Blake Griffin, something in there. So we want to offset this non-essential that describes the following subject with a comma. I like number 1. So that means that this is wrong, and this is wrong, because none of them have number 1 as an answer. Now, you said 1 and 3. So, real quick, Eric, what type of comma is this, and what is it making a non-essential? And then, if that's a non-essential, take it out and see if the sentence works without it. And I'm going to erase this to stall for you. It's really cold, Bird.
I know, man. You'll be
Yeah.
okay.
What is that from?
That seal is from a rose.
Okay. Yes, it is. It doesn't. Very good, it doesn't. So, that's, I would recommend looking at Reddit for ACT. Yeah, no, we're gonna check, we're gonna check it out. We're gonna check it out. It'll come out eventually to see what they were saying. Yeah. So, this one, and Gamer, let me know if this makes sense to you. This is some of the more esoteric comma stuff. So we have this non-essential here. Always remember, if you're dealing with non-essential commas and you're just not entirely sure, and even if you are entirely sure, take out the non-essential that you've just assigned and make sure the sentence makes sense. You always have to do that. No, it's not tested a lot, but it does come up. This is what I call a title. Okay, so this is the thing that throws people off, because if we say Blake, a student, studies hard. This is easy. This is your non-essential. You offset it with commas. This is super common. Or you could say a student, Blake, commas, studies hard. Yeah? Same deal. That's not the case here because we are missing our article. Okay? Now you don't have to think about it that way necessarily, but think about it this way. This is a title. It's Student Blake Griffin leapt in the air. Or President Donald Trump goes to Spain. Or something like that. You wouldn't say President Donald and then comma Donald Trump comma goes to Spain. Right? So you don't have to use either of these commas, and you shouldn't. If you put both of them here, so you want this comma for this non-essential. Then if you might think, okay, well I'm going to make the name a non-essential, so I'll put it there and there. But then you take that out and you take that out. You're left with student leapt in the air. That doesn't make sense. Ideally, your gut feeling will make that painful for you, and so you know it's wrong. But also it's because you're lacking the article for student. So if it says the student leapt in the air, that's fine. Or a student leapt in the air, also fine. We don't have that article there, so it doesn't work. You couldn't say it's just this one and say, student is the non-essential in the front, because then you have two non-essentials. Then you have Blake Griffin leapt in the air. That's fine, but then this isn't describing Blake Griffin the correct way, because that non-essential has to make sense, and it's not Blake Griffin. It's not Blake Griffin is student. It's Blake Griffin is a student. So you still need the or a. It still doesn't work. This is a title. It's like president. It's maybe you've seen this as some sort of newspaper title. Student yada 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 does this, or professor something does this. So it's a title. Be aware of that. Painter Michelangelo painted the Sistine Chapel. You do not need the commas there. Be aware of that. It does come up from time to time. Okay, they had a really bad one that could have been used. It was about dog sniffing or digging up plants. Sniffing the plants or digging up the plants. What's the verb in this sentence? He is going to the airport. Is it is going? It's is. The verb is there. Okay. Yeah, the active verb, or the important one, is. They're both verbs, but we're always focused on the active verb because there are lots of verbs in in many of the sentences on the test. You need to find the active one. You don't have to worry too much about helping verbs. Your gut feeling, Eric, I think is good enough. Just make sure that it is active. That's going on. Ow, dang it. Bird?
Yeah?
I bit the inside of my cheek.
Just go back in time and don't do it.
I can't. Okay. Yeah, I think that people do miss a lot of the helping verbs. You don't have to. What saves people is getting rid of non-essentials and reading the sentence. That is the most useful thing that I've found. Get rid of your non-essentials, read the sentence without them. It will generally jump out at you that it is a full independent clause or not. They are all over the place. Do you have any questions on this? Yeah, Gamer, I mean, any questions that anybody wants to ask at any point, well, not any question, but like, yeah, I mean, you can ask any questions about the tests. Yeah, once they come out, that'd be great, because then we have access to the actual questions and we can see them. But I don't know if you've watched our stream before, you can post, screenshots in our Discord, and then we can answer them there, that type of thing. Or just ask them in chat. Why is Seal stuck in my head, Bird?
Because it's a good song. Why do you think it's a good song?
Because it's stuck in my head?
Oh, I guess that makes sense.
So since it's just you two, and I'm a gamer, you seem fine with commas for the most part, or it seems like you're fine, and then Eric, you know all four uses that we talk about, then what do you want to talk about? We can talk about more of the science stuff if you have more questions, Gamer. We can talk about math stuff. We can, whatever you want to talk about. Brady. We can talk about Brady.
Yay!
Bird, come up here. Where's my...
Dude, I can't even move.
You can't move?
I can't move, man.
I'll help you.
Oh, thank you.
Yeah.
That'll work. Iron him up.
Come over here. Oi. Give me a math problem, or I can give you a math problem. What would you prefer?
Give me a math problem.
I'll give you a math problem? Okay.
We could do a cool probability one.
Yeah.
Should I get the list of problems out from yesterday?
What list?
Probability list? I got it from a worksheet. I didn't just make them up.
Yeah, sure. Oh, from Kuda?
Yeah.
Yeah. Ooh, no, we got Eric problems in the Discord.
Oh.
Very exciting.
Okay.
One of the problems dealt with integrals on the ACT. If it did, there was a way around it.
Yeah, there's no way that they would expect you to do that. That would be obscene.
Obscene.
All right, questions for stream. Eric TLT.
Oh, in the science section.
Oh, the science section.
Yeah, they
All
still
right.
don't require you to know
You
it.
didn't actually have to compute an integral. It's just probably finding the area under a graph or something. There's probably... Oh, Eric TLT. Very good.
Very exciting.
All right, so we got, looks like part of the answers here. A farmer observes that the demand for corn, Q... You want to draw this graph? Yeah, I see here. I get the other answers. Cool, cool, cool. Okay.
So demand for corn is Q.
Yes. Go ahead and draw this graph. Wait, no, we don't have the graph yet.
Just
okay.
Should I give the axes?
Here we go. Hold on.
Yes.
Oh, yes, yeah. Draw an empty graph with the axes. We got P and then we got Q. All right. Demand for corn and P, which is the price in dollars per bushel, are related by a linear function. If a demand of 2,500 bushels per month corresponds to a price of $4 per bushel.
Wait, it's per bushel, right?
Yeah. All right.
How do you spell bushel?
B-U-S-H-E-L. Yeah, bushel. All right, so here we go. Ready? You want to have, when Q is 2,500, P is $4. So when the quantity demanded is 2,500 bushels per month, the price per bushel is $4, and then a demand of 3,000 bushels per month, the price is $3.20. So as the demand increased, the price went down. That's the first big thing you got to think about here. This is a negative relationship. The slope is going to be negative. All right, as Q increases, P is going to go down. So letter A has, and guys, this is on the Discord, by the way, so you can check it out on the Discord. Letter A has a upward sloping graph, which is a positive relationship, and we don't like that. We want a negative one. All right, here we go, the second page. Letter C would also be positive. We don't like that. So either B or D is going to be our answer here. So let's make sure we have this right. So you got 4 and 320. Awesome. Awesome. Right. So both of these graphs have a y-intercept of 8, which is interesting. That means that when the quantity demanded is 0, the price is $8. And then they both go down and they hit different things here. So the way you want to do this is to just figure out what is the equation of the line between these. They do have the x-axis in terms of thousands of bushels. So this would be 2.5 and that would be 3.
Okay.
Yeah. What makes it a negative slope? A negative slope is when, as you're going to the right, it's going down. The reason why it's going down is if you think about it as quantity is increasing, price is decreasing. If two variables are increasing together, it's going to be positive slope. As x goes up, so does y, positive slope. If one of them is going up and the other one is going down, they have a negative relationship, which means they're going to be negatively, sloping. Sloping, I don't know if that's a word.
Sloping is a word.
Sloping is a word. Good. So we got 2.5, 4, and 3, 3.2. Awesome.
So you don't have to necessarily see this and then know, oh, that's negative slope. You can just graph it.
Okay, so, on math, it was easy. So, sounds good. So the slope here is going to be delta y over delta x. Our change in y, we're going from 4 to 320. So that's going to be 320 minus 4 over, and in this one we're going from, did I screw this up? 3.2
No.
minus 4, good.
Sorry.
3 minus 2.5. All right, so this is going to be negative 0.8, and this is going to be 0.5, which is negative 8/5. All right, that is our slope. And then, let's figure out our y-intercept is going to be 8. Because if you look at B and D, both of them have a y-intercept of 8. So right now I've got actually everything I need for this equation. Y is negative 8/5 x plus 8. And let's make sure we use the right variables here. Our y value is p. So this is p is equal to negative 8/5 times q plus 8. So the thing that's different, how do you know which one to subtract from?
It doesn't matter as long as you go in this. So if you do this y minus this y, then you have to do this x minus this x. If you do this y minus this one, you have to do this x minus this one.
Yes, you're going to get the same each. All right, so to find where it's going to hit the x-axis, that's where y is equal to 0. So we just have to put 0 in for y, which is our p-value. I know I'm going quick here. So we want to solve this thing for q, subtract 8. We have negative 8 is equal to negative 8/5 times q. They're both going to be negative, so the negatives are going to cancel out. To solve this, you want to multiply by the reciprocal 5/8. So this is going to times 5/8. 8s are going to cancel out. 8/5, 5/8, they're going to cancel out. You're going to get 5 is equal to q. So it's got to cross the x-intercept at 5, which means it is going to be the letter D. Letter D.
Yeah, so this is one of those intercept things where if you're looking for an intercept and you have your equation, you plug in 0 for the other variable. Always the case.
So Eric TLT, to answer your other question, which we already kind of did, I just want to show you. This is going to be equal to, if you flip which ones you're subtracting, you're going to get the same slope in both cases. But just keep in mind, I have y2 and x2, and I'm starting with, but over here I have y1 and x1. You cannot mix them up and have y1 and x2 at the same place. You have to subtract one full point from the other full point in a very full way. That's kind of fun. Right?
Mm-hmm. This is fun. It's 8:53.
Oh, that's a good time.
We got some time. This is a fun problem. You'll like this.
Really?
Yeah.
Oh.
We can do it together until
I
we
hope
go.
so. One confusing English question was labored upon versus labored over. That's an idiom question. So that's just, what phrase do you think, depending on what you've heard in your life, Yep. Do you labor over cooking? Do you labor upon cooking? I'm going to guess it is labor over.
Yep.
Yeah.
It's just an idiom. It's how we use the prepositions with certain verbs. There is no way, I mean, there is a way to study for it. You could study all the verbs and their prepositions, or you could read a lot. Unfortunately, those are just very hard for non-native English speakers and people who don't read a lot or have not read a lot in their lives.
Read. It's what you do. It's what's for breakfast and dinner. But not for lunch. Do not read while you're having lunch.
Yeah, because that's when Brady's not allowed to eat.
Yes. I don't eat lunch.
Ooh, I love a good erasing.
Don't you?
Yeah.
It's the best. It is the best. Okay. That song by Seal, huh?
Da, 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 da.
And you became my
okay, so why don't you read this while I draw?
pleasure.
Let me just look at the intercept. So
My pain.
-4.5. Oh, cool.
Baby. The lines F and G are graphed at left in the XY plane. Line G can be written as the equation y equals ax plus b, where a and b are constants. Which of the following represents line F? You don't eat lunch? I didn't have lunch today. I normally eat lunch, don't worry. Levi's just giving me a hard time because I didn't have lunch today. Okay.
Lunch didn't have you, and it talked to me about it, and it's pretty upset.
So, thanks, Levi. That's G, that's F. G, the function is y is equal to ax plus b, and they're wondering what would F be equal to.
Oh, this is way easier than I thought about. Okay.
These are the options.
You don't eat lunch at school? Oh, that's because, was it Eric who said that he's introverted? It's very hard to eat lunch when you're entirely introverted because your food just doesn't stay in.
Right, it comes out.
Because it's very hard to digest that way.
Yep. Okay. Okay. Interesting.
These are the answers?
Yes.
Very exciting.
So we've got A, B, C, and D. Put it over here.
It's flipped, so it'll work.
Right. No, that's fine. No, it's not. It looks exactly like what I expected to. All right, let's talk about the slope here. Our slope is A, and our G line has a positive slope because it's going up to the right. So we need to make sure that our F line has a negative slope. All right? So which one of these would have a negative slope? We got some weird things going on here. This one would have a positive slope because it's also A. So that one is not okay. We can eliminate that one. It's not going to work. This one here has a negative A as its slope, which means it's going to be going downward. So that's cool. We're not going to eliminate that. This one here is not solved for y yet. It's in terms of negative y, which we don't normally see. I would recommend, I just never school in the world school for this. What do you got, like sloppy joes every day? I could go for sloppy joe right now.
I sure.
Have you had a sloppy joe that's just like too sloppy?
I have.
Yeah. Okay. All right. We're going to take this over here for a sec.
Oh, we're going to take it right over.
Negative y is not cool. You want to solve things for y. Nice. So I need to multiply both sides by -1 to turn this back into normal y. So now it's going to be y is equal to negative ax minus b. And this one here is also not solved for y, which is weird. So Levi's going to go ahead and solve it for y. Look at that. Look at that. So we have y is equal to 1 over a times x minus b over a. All right, now... Oh, no. Hello, I'm late. Eric,
no.
Hello, how you doing?
How are you?
We're very excited to finally have you.
Right, and you've been looking forward to this.
We've been talking about you this
Right.
whole time.
We're ready to give you your bat mitzvah.
Okay, so let's talk about this now. This has a negative slope as well. Fantastic. This one here would have a positive slope. A is a positive number. 1 over a would still be positive, so this one we also cannot have. So D is out of the question. B and C are the ones that are left. We either have negative ax plus b or we have negative ax minus b. So B is the y-intercept. Our first line is G. The y-intercept of this is positive b, but if you look at where it actually crosses the y-intercept, it's negative. So B, therefore, is a negative number. We're adding b, but b is a negative number. If you had alt ipsum, you wouldn't have been late, just saying. That's very true. That's very true. But our F line has a positive y-intercept. If b is a negative number, the only way to make it positive is to subtract it. So it's going to have to be this one right here, which is c. Because b has the same y-intercept as the original line, as an answer choice b. This y-intercept is still plus b, this is plus b. That means that they would both be going through the same y-intercept. Not true. It's going to be c. All right, I got to get out of here.
You got to get out of here.
I need to get out of here. This place is about to explode. Do you think it was harder than usual because of the college admission scandal?
No.
Nope. Good question. Answer is no.
That test was made far in advance. Maybe not far in advance, but well in advance of that scandal. Maybe not the scandal actually occurring, but the scandals. Scandal. Hey, Hono, you're here. Do you have any questions? Eric, do you have any more questions? Gamer, do you have any more questions? Also, Bird has a child. I don't know if he said that. Hey, since Hono missed the spiel today about Alta Ipsum, which is not here, this is our private tutoring, if you want private tutoring. Oh, very good. Okay. You posted more, you're saying? Are there more? Okay. I don't know why I didn't realize that. Eric, can you give... Can't remember. Okay, that's cool. And concept-wise, you're fine on all the sections? Don't know. They're... At the end of the day, gamer, it just doesn't really matter how difficult the test is unless you're a bad test taker or a good test taker. If you're the type of person... I mean, because there's a curve, right? So you're still being graded in relation to other people. So it's going to be pretty comparable. I don't know. It changes. There's always something like, oh, this is way easier than normal. This is way harder than normal. And there's no normal. They're making new tests every time, and they're not perfect. Can I repeat what? Uh-oh. Missed this. I don't have questions today, Sarah. Oh, no. Yeah, can you repeat that? The closer the main test gets, the more anxious it leaves me. Ah. Oh, you have more. Okay, got it. Thank you, Eric. What am I repeating, Eric? Gamer, I don't know. It just depends on too many different factors for any. Like, I could tell you yeah, and I could be wrong or I could be right. I don't know. And anybody who says they know either, is basing it off of stuff that might not end up being true anyway because the thing is constantly changing, or they actually have insider information, which is possible, but unlikely. Ooh, okay. Oh, I was asking Gamer if Gamer had any concept related questions versus general test questions, like at the higher level of tests in general versus like what you're asking, which are basically concept questions. Okay, so you have this equation, y plus 6 equals -3/2 x minus 8. -3/2 x minus 8. And we are looking to graph these things. Okay, you don't know how to graph something that looks like this. This is in, what is this called? Not slope-intercept form. Point-slope form. This is called point-slope form. Doesn't really matter. Okay. For this one, you want to get it to y equals mx plus b, I think, probably because you know how to graph something that looks like this. So let's mess with the equation until it looks like that. That's generally a good approach. Yeah, ellipses happen too. So these parentheses don't need to be here because they don't actually do anything. But I'll leave them up. I'll just ignore them on the next line. So y plus 6 equals. And now I want to get it in y equals mx plus b form, so I don't want this garbage going on, so I'm going to distribute here. So I'll get -3/2 x plus 8 times 3/2 is 12. so plus 12. Then I'm going to subtract 6 from both sides. So I distributed on the first round. Subtract 6, I get y equals negative 3/2 x plus 6. This is our equation in slope-intercept form. So if we're going to look at the answers here, oh no, these are all Eric's questions in the Discord. You probably knew that if you cared. So we have an intercept of 6, so A could work, B could not work, C could not work, D could work. We have a negative slope, so D is wrong, so therefore A is the answer. Makes sense, Eric? So A is the answer because it has the correct slope and correct intercept. On both of the last problems, now I think the last problem was much harder because it had variables where you're used to seeing constants, variables. But it's still all the same concepts. If you're dealing with graphing and you have an equation, you're probably going to be doing y equals mx plus b, right? You're not going to just throw Pythagorean theorem at something, right? There's a recognition stuff always, right? If you're dealing with graphing and the functions are linear, then you can write them in y equals mx plus b form. That's where you want to go because you know stuff about it. Okay, good. I'm glad it makes sense. Let us do the next one. Dang it. Okay. Ooh, this one looks exciting. Okay, so we have, oh boy, got lots of stuff going on. So z plus w minus 3 equals k. Z plus w minus 3 equals k. 6z 10w 8. 6z minus 10w equals 8. Consider the system of equations above where k is a constant. Okay, ooh, this is going to be fun. For which value of k are there infinitely many? Ooh, okay. K value that gives us infinite solutions for, what was it, WZ or ZW? I think it was WZ. WZ. Okay. This is something that I think we've gone over for, maybe, I remember Hono and Eric working with you guys on the mirroring problems. I hope those are okay now, maybe. Maybe you've seen them again, maybe probably not. This is number of solutions. You want an infinite number of solutions. It's still coming back to this. It's not always going to come back to that, but it often does. So WZ, and we have the variables W and Z here. K is not a variable, it is a constant. You don't know the value of it, but it is a constant. So this would be graphed on the WZ coordinate plane. We could also do X and Y. And I think that's what I'm going to do just to teach this because it shows you that you can go from that weird stuff to stuff that you're a little bit more used to seeing. So let's rewrite this stuff as it's WZ, so W is X. So Z is Y. So we have Y plus Z minus 3 equals K. And we have 6Y. Why did I do? No, sorry. My bad. This should be X. Minus 10x equals 8. Okay, so this is our system of equations. Now, in a system of linear equations, you have three options. Okay, you have two lines. There are three things that could happen. They could intersect at one point. They could be parallel and never intersect. So this is one solution. This is 0 solutions. Or they could be the same line on top of each other, so that's infinite solutions. Do those three options make sense? Because this is important to think about. When you start dealing with number of solutions, things change. You're going to be you're trying to set up a situation where you have, in this case, the same exact line. That is what you need. Is everybody who's watching and caring following this idea? I hope so. Now, nobody's answering, so I'm gonna go with yeah. We'll go with yeah. Now, here's the deal. We need to make these things, if we have the equation y equals 2x plus 3, and we want another equation that gives us infinite solutions if we're finding the intersection, or the number of solutions for a system of equations, the next equation, we need to be exactly where did I get that? I know where I got that, but that's wrong. It needs to be exactly the same thing. Yes, I did. Very good, Eric. You're very good at watching this stream because you know what we're saying and asking all the time. So we want this to happen, right? Because this means infinite solutions, right? This will be the two lines on top of each other. That's supposed to be on top of each other. So we have infinite solutions. That's what we're going for. So we're going to put each of these in y equals mx plus b form and see what happens. So this guy, we're just going to subtract stuff, right? We're going to take off the x, we're going to add the 3. So we get y equals negative x plus 3 plus k. So this right here is our y-intercept. And then this one, we're going to add 10x and then divide by 6. So we get y equals, instead of let me look at the question again. I assumed it would work, but now I'm not so sure. Awesome. WZ, let me just make sure I converted everything the right way. WZ, so XY, WZ, so XY, 8K. How is this the y-intercept? Because this is in y equals mx plus b form, right? That's what we're going for. B, because you have y, which we have. You have mx, that's negative 1x, so that's your slope and your x, and then you have your y-intercept. That's just the constant at the end. So we have plus 3, but we also have plus k, which is a constant. Okay? So everything that's not attached to the x in this formula will be part of that y-intercept. Does that make sense? Just because there are two, we just can't combine them, right? If k were 10, then the y-intercept would be 13, right? So I'm not saying that all y-intercepts have a k in them. I'm just saying that in this case, we don't know what k is yet. We're going to try to figure it out. So it's part, that whole thing is the y-intercept. We just don't know what k is. Now, the next one, we add 10x, divide by 6, so we get, I'm going to simplify that fraction. You know what, I'll do it in steps. So 6y minus 10x equals 8. We're going to add 10x to both sides. We get 6y equals 10x plus 8. We're going to divide everything by 6. We get y equals, I'm going to simplify that, 5/3 x plus 4/3. Okay, so that's what I'll write here. Y equals 5/3 x plus 4/3. I'm going to erase this part now. I see a problem here, which is a little disappointing, but maybe we can go over ones that actually work after this, if you want to keep talking about it. Because these are not super common problems, but you're dealing with this, which is a super common thing that you need to be able to mess with at all times for the rest of your life. Not really for the rest of your life, until this test. And then maybe you can forget it, unless you want to be a tutor. Okay, so we have these two equations. And this is our y-intercept. This is our slope. We have y and x. So here's the problem. You want to get to this point, right? You want to have an identical slope and an identical y-intercept. We don't have an identical y-intercept, or we can figure out a value of k, right? You want the y-intercepts to be the same because you've set up these equations to be identical. So we want 3 plus k to be equal to 4/3. So we know that for this stuff to work, subtract 3 from both sides, we get that k equals 9, 5, so negative 5/3. That's what k would have to be to give us infinite solutions. But it's not good enough, because that would give us the same y-intercept, but the slopes are not the same. We have a slope of -1 and we have a slope of 5/3. So we're going to get some graph that has the same y-intercept, which is 4/3, sure. So if we're just making these big like that, we have 4/3, so it's about here. These two graphs have the same y-intercept, but this one has a slope of -1, so it's going to look something like that. And this one has a slope of 5/3, so it's going to look something like that. So these very clearly cannot possibly have infinite solutions. So the answer to this one is none of the above, or no value, or whatever it was on the question. We are trying to make these two given equations look like this. They need to have, just everything needs to be identical when you put them in this form. But we failed to do that because the slopes just aren't the same. Does that make sense, Eric? And Hono, and Gamer if you're still here. And anybody else. Also, we're doing these questions. If anybody else has more questions, please put them in the Discord or ask them in chat, and I will answer them to the best of my abilities. Do you have any questions on this, Eric? Did I just ask that? I probably just asked that. I would like to do another example of this type of thing that actually would work. Kind of. Okay, let's do another one. This is not a good learning one because it doesn't work, so it's not that helpful. So I'll just erase everything. I'm going to leave that up. Yeah, there were a lot of steps in this one that didn't actually end up doing anything nice, so it's hard to understand. That is a strong smell of vinegar. But Alta Ipsum will help with that. Okay. Let's see if I can think of a nice equation to do, or system. Now we have infinite solutions, 0 solutions, and 1 solution. So let's do infinite solutions again. Let's just use x and y. It's just simpler. So we have this system of equations, and let's say we have 2x minus 3y equals k minus 2. Nice. Good. I'm looking forward to it. 2x minus 3y equals k minus 2. And then let's say that we have, let me think, sorry. 9y, negative 9y, plus 12. I don't know. We'll see how that goes. Okay, so same situation. We want, yeah. This will work. Where did it go? We want a system of equations that gives us infinite solutions. So we want them to be the same line. Also, just to get you thinking about it, I also will want, I'll write this too, there are more values of k for this, but a k value that has 0 solutions, or a k value that gives us 0 solutions for x, y. So we're getting to that eventually. Let's do yellow. So we're going to put these in y equals mx plus b because we just know, we feel good about that stuff. This doesn't really relate itself to anything for us. So the first equation, we have, I'll do it up here, 2x minus 3y equals k minus 2. So we're going to subtract 2x from both sides. We get negative 3y equals negative 2x plus k minus 2. Then we're going to divide everything by 3, negative 3, sorry. So we get y equals negative 2/3, or negative 2 divided by negative 3 is 2/3, plus k minus 2 over negative 3. That is our first equation. Okay? Next equation. Just do it here. We're going to subtract 12 from both sides. So we get negative 9y equals negative 6x minus 12. We're going to divide everything by negative 9. We're going to get y, I'll write it down here, y equals 2/3 x. That is 4/3 plus, 4/3 again. Cool. So here's our system of equations. We have 1, we have 2. What is the x? Hey, Neutron, what's up? X. What is the x? Did I mess up an x? Where is the x? I forgot. I forgot an x somewhere. Yes, I did. You're right. Thank you. Plus. Yes. Okay. Yes. Thank you, Neutron. Hey, Neutron, I don't know when you started watching, but we did matrices at the beginning of the stream. If you have any really specific question about matrices, I'm happy to answer it. But Brady did a general overview of adding, subtracting, multiplying. I forget if he did determinant. I think he did. And that's all there is. Aside from doing context-related problems with them. Okay. So, are you guys with me to here? I should rewrite these better. We have y equals 2/3 x plus 4/3. We also have y equals 2/3 x plus k minus 2 over negative 3. What are we going to do next? These are our two equations. We want a value of k that gives us an infinite number of solutions. That's what we're doing first. Oh, you did? Awesome. Do you have any follow-up questions, Neutron? And what are we doing here? What's our next step? I'll wait. I can. Is there another Discord question? Is that what was happening? No. Reminder to send one of my students her homework. Oh yeah, we already did this one. Do we have one more of your questions, Eric? Yeah, we do. No, we have 2 more. Awesome. Nope, it was enough. Awesome. Cool. Solve for k. Yes, we solve for k. How do we solve for k? What equation do you set up involving k and no other variables so that you can solve for k? Yes. What do we set k equal to? Yes. Okay. Yeah, so we want them to be identical, right? We want infinite solutions, which means they just have to be the same line. They have to be exactly the same line. So we have the slopes. They have identical slopes, so that's step 1. And now we just want them to have identical slopes and the same y-intercept, so we know they're starting the same place, and then they're just the same thing. So that means we need to set these equal to each other, as Neutron said. That's what I'll do. Yellow. 4/3 equals k minus 2 over negative 3. I'm going to multiply each side by 3. Those go away, those go away. Don't forget the negative. Let's put it over here. So we have negative 4, I hope that made sense, equals k minus 2. Let's just multiply each side by negative 3. Make you happy? So that goes away, that goes away. That negative goes in front of the 4. That's not something that you need to think about. And then we add 2 to both sides. We get k equals negative 2. That is the value of k for which we have infinite solutions to that system of equations. Now, For what value of k do we have 0 solutions to that system of equations? We did all of the work necessary. This is a much easier question. Or it requires less busy mathy work. But the concept is still the same level of concept. 0 solutions. They need to be parallel lines and they can never touch. So let's see. We have parallel lines. In this case, in the first case, we made them with the same y-intercept. So now we just want the value of k that gives them different y-intercepts, because if they have different y-intercepts but the same slope, they'll be parallel. They will have no solutions to their system because they never intersect. So let's just say k is 1,000. If k is 1,000, you have no solutions. If k is anything aside from -2, you have no solutions. Yes, it could be, so k can be, to answer this question, k can be anything except for -2. -2 is the only value of k that gives you infinite solutions. Is everybody who didn't understand that before full of joy and understanding and a sense of oneness and connection now because of this? Or no? I'm happy to talk about it more. This was probably misleading and distracting, this part. Seems like it's fine, unless there's just a giant lag for the stream, which I don't think there is. Great. So that's infinite solutions and 0 solutions. For one solution, well, in this case, you actually can't have one solution, right? For these, because when we put them in their slope-intercept form, they had the same slope. So if two lines have the same slope, they can't have one solution. They have to have infinite solutions, because they're the same line, or they have to have no solutions, because they're parallel. In the last one, I think, well, they had different slopes, so they have to have one solution. So you could set something up like that, where k would end up being your coefficient for x in one of them. And then you just have to solve for a value of k so that you have one solution, something like that. Same idea. But these are all coming back to, if you have an equation and you're doing graphing stuff and intersection stuff, get them into y equals mx plus b form, because you know how to manipulate that. You can manipulate equations to make them look how you want, and then you understand what the pieces of the equation mean. That is interpreting equations. That's manipulating equations and variables. Very, 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 very important for the SAT or ACT. And ACT, not or. Where did we get all this vinegar? So Eric has another 2 questions in the Discord. I'm going to do those unless somebody else has a question they have a burning desire to be answered. Oh no, you seem to be happy to just come along for the ride on this type of thing. And it's cool. Quick question. Do you recommend taking both the SAT and ACT? No, I don't. I do recommend figuring out which one you're better at. So, and that doesn't have to be done officially. You can, there are obviously a bunch of practice tests. You could do a practice test for each and then compare your score. If they're comparable, do the test you're more comfortable doing. If they're not comparable and one is way, way better, then just probably do that one. So if you've been doing one of them for a while, you're probably more comfortable with that one, and if you don't have a lot of time to prep for the other one, then I would say stick with the one you have. If you have a bit of time and you're not improving much on one, then maybe try out the other one, not officially, but just do it on your own, do a test, see how your score comes back without much prep. If it's close to the one that you have been prepping, then you should maybe consider switching. Yeah. Can we go over a geometric series later? Oh, yeah, we can. Oh, you know what? Let's do geometric series now. Thank you for the question, Neutron. Eric, we'll get to your questions tomorrow. Yes. Okay, so geometric series. That is going. There are a couple ways to write them. You don't have to come up with those things. There are a couple things that people freak out about. generally, but a geometric series just giving you what one would look like is, let's say 3, 12, what did I just do? Okay, so 48, 200, 192. So clearly we are multiplying by 4 every time. So a geometric series is when you are multiplying by a number to get from your current item in the set to the next one and the next one. Now, there are series and sequences. Sequences are just, this is a sequence. A series is when each item in the list you're adding to the previous one. So this is still geometric. This is a geometric sequence. This is a geometric series. They will not make you differentiate between them. They don't act differently. I mean, this one, the sequence, you have the numbers. In the series, you're adding them up. Series are what gets dealt with as you get higher and higher in mathematics because interesting things happen that also make your brain hurt. They're not going to test you on the difference. They don't care about the name of it if it's series or sequence, but just so you know, that's what's going on. I can't remember. I don't think I've ever seen where diverging and converging series on the SAT or ACT, so I wouldn't worry about that. So ignore what I just said. But this is what's going on. Okay, so this is still the same thing. You're just adding the items instead of putting them out there. Now, this thing that you're multiplying by each time is called R. R is your multiplier. I actually forget the word that it is, but this is the thing you multiply the previous term to get to the following term. Yeah? Or the current term. Now, there are ways to write these things. So if you have, you can write it several, there's a recursive way, and then there's the, not direct. If somebody else knows the word, it's not recursive, it's the other way of writing these. But, and let's see if I remember the formula or can come up with it now. So, whatever number you're on, you could write it like this. A to the n minus 1. So this is what people trip up on a lot, is the notation of series or sequences. So whatever number you're on, so this is A, this is the item in your sequence or your series. Whatever number you're at there, you're going to take the previous one and multiply by R. Right? That's just literally what happens. If this is your nth term, this is your n minus 1th term, n minus first term, right? And so the way you get from the n minus 1 term to the nth term is you multiply by R. That's all that this says, okay? Now they might give this to you, and then, so I'll give you a problem there. So then the other way to write this is recursive, because it's using the previous one. Then the other way is saying that a sub n equals a sub 1. So you start with the first term. Now you have to know the first term, so we'll get to that. Times, oh boy, let's see. It's r to the n minus 1 power. Okay? Now this makes sense because if this is your a sub 1, this is your a sub 2, a sub 3, a sub 4th term. And let's say a sub 1 is, and then it'll give you a sub 1 is 2, or 3 in this case, right? So if you're given this, you have to know your first term. I think it's, you basically for either of these you would need to know your first term, or in this one you could say 3. Okay? So it just depends on how they write it. But you should be able, what people trip up on is, how did I miss that? Frustrating. The n, the subscripts, right? That n minus 1 is not something mathematical. It's just, it's notation to describe what term in your sequence or series you're on. Okay? So if I say that we have this series and we have n, or a sub n equals a sub n minus 1 times 2, okay? And I say that my a sub 8th term is 68. Okay? And then the question is, what is my a sub second term? Okay? So that's what we're dealing with here. You could use this stuff. There are ways that people learn when they're in, I think, Algebra 2 normally, where they do this, and there's a specific way to do it. I don't like specific ways of doing things. I like understanding what's going on. So we have this a sub 2 term, and then we have a sub 3, and then we have a sub 4, and then dot, 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 we have a sub 8, right? And every time, we are multiplying by 2, right? That's what this is telling us. We have whatever we're on, and you take the previous one, you multiply by 2. So this is your r, yeah? So you multiply by r, or multiply by 2, right? So how many jumps are you doing to get to 8, right? You do 6 jumps. So 6, call them jumps. You're multiplying by 2 6 times. Now be very, very careful here. It's not 2 times 6. You're not multiplying by 12 to get from 2, with the second term, to the 8th term. You're multiplying by 2 to the 6th, because you multiply by 2, by 2, by 2, by 2, by 2. So times 2, times 2, times 2, 6 times is going to be 2 to the 6th power. So you know that if you have a sub 2, you're going to multiply that by 2 to the 6th power, and that will give you 68. So now you just have an equation, and you want to solve for a sub 2. So 2 to the 6th is 2, 4, 8, 16, 32, 64. That's stupid. Why would I do that? 64 equals 68. So now we just divide both sides by 64. We get a sub 2 equals 68 over 64, whatever that is. And that would be your second term. Neutron and Eric and Hono and anybody else who's here, does this make sense, this idea? It is about understanding. This is what I would recommend. This is everything right here. This idea will get you everywhere you need to go in these problems. Okay? Now, this is geometric series. So the same thing goes for, let's do it in blue since we haven't done that yet. If we have the same stuff, same setup, but now, instead of multiplying by 2 from the last one, we're going to add 2, right? So we're just getting 2 bigger every time, which is a simpler concept. But same situation here. So we have a sub 2, a sub 3, dot, 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 a sub 8. We add 2, and so on. Now here's the difference. When we get from, we want a sub 2, and instead of multiplying by stuff, we're adding every time, right? So we have to do plus 2 times 6, not 2 to the 6th power, because 2 to the 6th power came from multiplying by 2 every time. Now we're adding 2 every time. So you're doing a plus 2 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 plus 2, whatever it was. That equals a sub 8, which is 68. So this is a sub 2 plus 12 equals 68. So a sub 2 equals, subtract that, we get 56. Okay? So those are just totally different situations. This is about as hard as it's going to get. What I have seen, and sometimes this is harder than I've seen almost all these problems. They'll generally give you the first term, and then you have to find 7 terms away. And they make it so that, yeah, you could brute force it and say, okay, I'm going to multiply, and they'll give you worse numbers. So it's not going to be multiplied by 2, but maybe it's multiply by 3/8 or negative 3/8. And you're doing the same thing. It'll be negative 3/8 to the 6th here, or something like that. They'll give you the first term, you have to find the 12th. So you could brute force it, but it'll take you 10 minutes. Or you can know, well, I'm going from the first term to the 12th term, so that's 11 jumps, and I'm multiplying by negative 3/8 every time, so I'm doing a sub 1 times negative 3/8 to the 11th power, because I'm multiplying 11 times, equals a sub 12, and then you solve from there, okay? So that's geometric versus oh gosh, arithmetic. Yeah, arithmetic sequences series, geometric sequences series. Any questions on this? Have you seen questions that don't follow this pattern for whatever reason, or ask something that doesn't quite make sense with this stuff? Please let me know. I'm gonna say yeah. Guess I could answer my own question. Yeah, I'm gonna start erasing. So that's sequences in series. You don't really need to think much about the difference. They won't ask you about the difference. They'll just give you a situation. You can deal with it, I'm sure. With this, just make sure you're not trying to remember these formulas or anything. They're useful, but what's more useful is being able to picture the steps between pieces of your list or your series, okay? Okay, I'm going to head out, but we're back tomorrow. We might also have a new intro tomorrow. Or we have a new intro already, the countdown thing. It's gonna same countdown, but we're gonna have a different song this time, and it's gonna be dumber than last time. It's not really a song at all this time, or it's not. It wasn't a song last time. Just stop talking. Seems like nobody has any other questions, anything else to say, so I will see you hopefully tomorrow for the last day of the week. Come with your questions, please. I don't like begging. Well, no, I don't like begging for questions. So it would be ideal if you do some practice, find stuff that you want to ask questions about, ask them, we'll knock them out. Have a good night, Hono. And what? Is that last one? Okay, night.